In this video you will learn what is network address translation, but we're going to do it different today. It's going to be more fun and exciting because you will learn it through a fun live demo. Let's take a look at where and how network address translation is used. The one that you're probably familiar with is your Wi-Fi router that you're using at your home. Network address translation is used in your Wi-Fi router so you can have internet connectivity without actually having a public internet routable IP address on your laptop or your mobile phone. Second, load balancers. Load balancers often rely on network address translation as well to forward traffic to the backend or to send traffic back through the load balancer back to the client. Third, cloud providers. In cloud providers, you often have private VMs that are only on a private network and they don't have a public internet routable IP address. The cloud provider often have a service like a cloud NAT that provides network address translation such that your private VMs can have internet connectivity without requiring a public internet routable IP address. Network address translation is also used in Kubernetes, where it's used for providing internet connectivity to pods and to implement Kubernetes services, which are basically load balancers inside of Kubernetes. Now it's time for the fun part of this video. We're going to learn more about network address translation by actually implementing it to solve a real problem. In this environment, we're going to have three VMs, VM1, VM2, and Router 1. VM1 and VM2, they only have a private IP address and they have no internet connectivity. Router 1, on the other hand, has a private IP address and also has a public internet routable IP address and is able to access the internet. Now, how can we get internet connectivity on VM1 and VM2? That will be the exercise of this live demo. So we have Router 1 here and we have the VM1 here, and let's first show that this is actually not working right now. So right now VM1 has no internet connectivity. As you see, it fails after 1 second and says connection timed out. Now at the same time, let's also confirm that Router 1 is getting the traffic when we're trying to curl ifconfig.me. We're going to do another request, and as you will see, it's still timed out, but we do see the traffic coming in from my host VM1. This is the VM1 IP address, and this is the destination IP for ifconfig.me. So that's actually looking good. Now what we're going to do next is we're going to implement source network address translation by using IP tables. First we're going to make sure IP forwarding is enabled, and then we're going to add a masquerade route to masquerade all of the traffic coming from the source that has this whole CIDR that is used for private IP addresses. So let's do another request. Actually, now that we have implemented IP table, internet connectivity should start working. Before I do that, let's start up the TCP dump again. And as you see, it actually worked this time. It actually returned. It returned my IP address, which is the IP address of Router 1 and not of VM1 itself. You just saw in the live demo how we used IP tables to implement network address translation so we could provide internet connectivity to devices that didn't have an internet routable IP address. But how did it actually work? Let's take a deeper look by inspecting the packet flow of an example packet from VM1 going to a website that's on the internet. So we have the packet coming out from VM1, which would have the source IP address set to be the IP address of VM1, which was 192.168.0.3. And then when that packet gets sent to Router 1, it would, before it leaves Router 1, the source would get translated to 35239.31.205, which is the internet routable IP address of Router 1. And then when the website gets it, it will send a response back to the source that the website saw, which was Router 1. So the website got the packet and then sends it back to the source, which is in this case Router 1. And then when Router 1 gets the packet, it will change the destination to be VM1, and then VM1 is able to get a response back from the website. And that's how NAT is able to provide internet connectivity to a VM that does have an internet routable IP address.